All right, ladies and gentlemen, here's your notes for set 55, abstract equations and word problems with quadratic equations. So these first ones aren't anything terribly new. It's just amping it up a little bit. We are still going to multiply by PD. So I get D times X minus A minus CPD equals KP. Okay, and so I'm solving for A. So I need to distribute in the D and get dx minus dA minus CPD equals KP. Okay, we're going to move everything over that doesn't have an A in it. So I'm going to subtract over my dx and add my CPD. And then I'm going to divide everything by negative d. And so I'm just going to flip KP minus dx plus CPD over negative d, or if you want to, you can move the d out of the the negative out of the denominator and switch the signs of everything on top and have it over a positive d. Okay, so that was solving for A. So we just are going to add in, instead of just monomials, now we're looking at we have a binomial. So this one we're going to solve for P. So we're going to multiply everything by K times X minus P. Okay, so we get AK minus CK X minus P over Y times X minus P. I'm going to distribute in my terms. And then I end up with minus CKX plus, because two negatives makes a positive, CKP equals YX minus YP. Now I'm solving for P, so I want everything that has a P on the same side. So I'm going to move this term over and move this term over. So I have AK minus CKX minus YX equals negative YP minus CKP. All right, I'm going to divide out that P. So everything's the same on this side. And I have out a P. So I have negative Y minus CK left. I'm going to divide both sides by that. So I have AK minus CKX minus YX all over negative Y minus CK. And if you want to pull the negative out of there, then so it's not in the denominator, you get P equals negative AK plus CKX. Everything just gets changed for signs in the top, and the bottom becomes Y plus CK. All right, so again, nothing terribly difficult or new, it's just adding a little bit to it. Same thing here is we have some word problems, and the word problems we're going to see quadratics appear. Find 4 consecutive odd integers. So I'm going to say n plus 2, n plus 4, n plus 6, so that's 1, 2, 3, 4 terms, such that the product of the third and the fourth, n plus 4 times n plus 6, is 49 greater than the product of the first and the number 10. Okay, so on my left side here, I'm going to FOIL or box method, and I end up with n squared plus 10n plus 24 equals 10n plus 49. I see I have a 10n on both sides, so they are going to cancel. And I have n squared plus 24 equals 49. So to be able to solve for this, because n is squared, I have to subtract over my 49. So I get n squared minus 25 equals 0. So we have a quadratic here. We actually have a difference of perfect squares, which turns into n plus 5 and n minus 5 equals 0. So my two n's are negative 5 and positive 5. So then, because remember it asked for 4 consecutive odds, I need to come up with what the other 4 are. So I have negative 5, and then that's going to be negative 3, and negative 1, and 1. And then if I have positive 5, it's going to become 7, 9, and 11. So when I have quadratics appear in these word problems, I'm going to have multiple possible answers. I either have the first set or the second set. All right, there you guys have it.